Welcome to my lecture on gully development, its classifications, control measures that are classified into two temporary and permanent gully control structures. So we see this one by one. We have seen some part of gully erosion, that is an advanced stage of real erosion. So the concentration of surface runoff, that is the water with high velocity moving over the surface, it is a potential source of gully erosion. It is defined as a channel or miniature valley cut by concentrated runoff through which water commonly flows only during and immediately after heavy rains. It is estimated that in India the rate of soil erosion from gullies is about 33 tons per hectare per year. So that much soil erosion per year occurs in India. The distinction or difference between ravine, gully and rills is that of the size. Gullies are too large to be filled by normal tillage practices, so conservation techniques cannot be applied for gully erosion control. Ravines are a deep, narrow gorge. It is larger than gully and is usually worn down by running water. It is estimated that about 4 million hectares of land in India are affected by gully erosion. So we'll see what are the stages in development of gullies. There are 4 stages. We will see first stage is the formation stage, that is the topsoil is scoured. Scoured means it is removed and in the direction of general slope occurs as the runoff water concentrates. As the runoff water flows over the soil, the slope occurs and the topsoil is scoured in the direction of the runoff water. It normally proceeds slowly where the topsoil is fairly resistant to erosion. As the topsoil is fairly resistant to erosion, it is a slow stage. Second stage is development stage, in which upstream movement of the gully head is caused and the gully is enlarged in width and depth. The gully will cut into sea horizon of soil and the parent materials are removed rapidly as the water flows. So this is a fast stage as the soil is removed rapidly. Third is the healing stage, in which vegetation starts to grow inside the gully. And the last stage is the stabilization stage, in which the gully reaches a stable position and sufficient vegetation will cover and develop over the gully, and new topsoil will not be permitted. We'll see what are the classification of gullies. First classification is based on the size, in which it is classified as small, medium and large. The depths and drainage areas are here to see. It is less than 1 for small gullies, less than 1 meter, less 1 to 5 meter for medium gullies, and greater than 5 meter depth for large gullies. Drainage areas will be less than 2 hectares for small gullies, 2 to 20 hectares for medium gullies, and greater than 20 hectares for large gullies. Second is the based on shape. Second classification is based on shape. It is classified as U shaped, V shaped and trapezoidal shaped. So U shaped are formed where both the subsoil and topsoil are equally resistant to water. You can see here this is a U shaped gully in which the topsoil, this is the topsoil, and below the topsoil there is a subsoil. So both these soils are equally resistant to the flowing water or runoff water against erosion. As a result, there is a uniform erosion occurring in the topsoil as well as subsoil. So that's how U-shaped gullies are formed. On the contrary, V-shaped gullies, in V-shaped gullies the subsoils are higher resistant than topsoil. That means the subsoil will have high resistance to erosion as compared to topsoil. As a result, the topsoil gets eroded more than the subsoil. You can see that's why this V-shaped structure or V-shaped gully is formed. Third third type is trapezoidal shaped gully, in which the gully bottom is made of more resistant material than the topsoil. You can see the substratum gully bottom does not erode at all. It is plain. There is no erosion occur. That's why it is very resistant to the erosion. In this case, the trapezoidal gully is formed. Next, on the basis of continuation of branches, it is classified as continuous and discontinuous gullies. In continuous gullies, these gullies are consist of many branches or net, and they form a network of gullies. A continuous gully has a main gully channel and many mature or immature branch gullies. A gully network is made of many continuous gullies. Second is discontinuous gullies. They do not have branches. They are also called as independent gullies. So these may develop on hillsides after landslides. We will see one by one what are the gully control structures, what are the structures that may be built to prevent or to control the formation of gullies. First is the temporary gully control structures, in which there are woven wire check dams, brushwood dams, loose rock dams, plan or slab dams, block check dams, boulder check dams. Second is the permanent gully control structures, that are drop spillway, drop inlet spillway, and third is the chute spillway, and last is the permanent earth check dam. First we will see what are the temporary gully control structures, as it is by the name temporary. So these are built for a very short lifespan of 3 to 8 years. Second, these are pretty effective where the amount of runoff is not very high. These are made of locally available materials that are readily available in the surroundings. The basic purposes of temporary gully control structures are they retain more water as well as soil for proper plant growth, as well as they prevent channel erosion until sufficient vegetation is established. So we'll see what are the temporary gully control structures. First structure is woven wire check dams. So these are made of woven wires. As the name suggests, the small barriers which are usually constructed to hold fine materials in the gully. These are used in moderate slope region, not more than 10%, and small drainage areas. They help in establishment of vegetation for permanent control of erosion. The shape of this dam is half moon shape. So amount of curvature is compulsory, but an offset equal to 1/6 of the width of gully at the dam site is optimum. So an offset should be given of 1/6 of the width of the gully, but that is optimum. So we'll see what is the construction. Before construction, we'll see the first point. A row of posts is set along the curve of the proposed dam at about 1.2 meter intervals and 60 to 90 centimeter deep. So these are called as posts. These wooden posts, or vertical lines are called as wooden posts. So these are around 60 to 90 centimeter apart. (60 to 90 centimeter deep and 1.2 meter distance between them. After that, heavy gauge woven wire is placed against the post. with a lower part in a trench 15 to 20 centimeter deep and 25 to 30 centimeter above the ground surface. So these heavy gauge one wire are placed 15 to 20 centimeter deep and 25 to 30 centimeter above the ground surface. You can see the top surface. These wires these are the wires that are 25 to 30 centimeter above the ground and 15 to 20 centimeter deep. Okay, so this is the current construction of one wire dams. Also, rock, brush or sod may be placed approximately up to length of 1.2 meter to form the apron. So this is the slope is the apron, is called as apron. The water will flow through this apron. Okay, so for this brush or sod or straw can be used. Rock, brush or sod can be used for a length of 1.2 meter. Also for sealing the structure, straw, fine brush or similar material can be placed to against the wire. This was the one wire dam. Second is the brushwood dams. So these are cheap and very easy to build but least stable of all the types. These are best suited for gullies with small drainage areas. Also, the center of the dam is kept lower than the ends to allow the water to flow over the dam than around the corners. So you see the construction. There are several rows of stakes and posts are same. There are several rows of stakes. They are with rows 60 centimeter apart and 30 to 60 centimeter stakes are apart. You can see here. You can see here the stakes or posts. Their distance is 30 centimeter, 30 to 60 centimeter. Minimum distance should be 30 centimeter and maximum should be 60 centimeter. Sometimes large stones can also be placed on the top of brush to keep it compressed. So you can use stones also, large stones also. The major weakness or problem or limitation is the difficulty of preventing the leakage of water. So you have to pay constant attention to plug the openings of the appropriate size with straw as they develop. So many openings or many leakages will develop over the time and you have to pay good attention so that the openings are closed with the straw. This is the major limitation. So this is the brushwood dam. This is the brushwood dam. You can see here this brushwood dam construction. So this is how these are called as posts, the vertical. You can see this. So this is how the brushwood dams are constructed. Third type of temporary gully control structure is loose rock dams or loose rock soil dams. So these are made of relatively small rocks. The main objective is to control the soil erosion across the gully bed and to stop waterfall erosion. The length of gully channel should not be more than 100 meter and gully catchment area should not be greater than 2 hectare. These dams can be used in all regions as stones are available everywhere. Suitable gullies with small to medium size of drainage area. So this is suitable for gullies with small to medium size of drainage areas, used in areas where stones or rocks are of appreciable size and quality. Suitable quality means the stone should be able to sustain water velocity. These qualities should be available. Then only these loose rock dams can be built. Flat stones are the best choice for this dam. Stones of there are stones of different shapes, so these stones can be laid in such a way that the entire structure is kept together so that there is no leakage of water. So if the rocks are small, they should be enclosed in a cage of 1:1. If the rocks are small, then the strength of these rocks will be less. So this dam, construction of this dam, a trench is made across the gully to a depth of 30 centimeter. So you can see this trench. So this trench is made of 30 centimeter depth, of a depth of about around 30 centimeter, which will form the base of the dam, on which the stones are laid in rows. So you can see the stones are laid in rows. So there are stones and brought to the required height. The center of the dam is kept lower than the sides. To serve as an apron, several large flat rocks may be countersunk below the spillway. So this is the apron. So many flat rocks can be used in this region for the drainage of water. So you can see this is the loose rock dam. Next is the permanent gully control structures. These are used if the erosion control program requires bigger structure or solid structure. So first is the drop spillway. First structure is the drop spillway, in which it is a weir structure in which flow passes through the weir opening, falls or drops on an approximately level apron and stilling basic, and then passes to the downstream channel. Its use is limited to a drop of 3 meters. So a water drop of 3 meter can be obtained by using this drop spillway without soil erosion. So it is mainly used at the gully bed to create a control point. So it controls the formation of gully as it controls the soil erosion. So you can use several such drop structures across the gully width throughout the length at fixed intervals. So this is how the drop spillway looks like. We will be seeing the components afterwards. So just look at this. There are different walls in the structure. We will see one by one. So this is the definition of spillway. It is a structure constructed at dam site for effectively disposing surplus water from upstream to downstream. So these are the components of drop spillway. We will see one by one. First is the head wall. It is a main weir wall over which water will fall on the apron. So this is the head wall. So this is the head wall. Second is the head wall extension. It is extending from inlet to both sides. So it extended from both sides to prevent the seepage of water. Third is the cut-off walls. This cut-off walls are the vertical walls extending into the soil foundation. So they go into the soil foundation under the inlet. After that, side walls. These are the side walls. These are extending vertically from outlet to wing. Next is the toe wall. So toe walls are vertical walls extending below the front of the apron. So these are the below the front of the apron to prevent undercutting of the structure. Next are the wing walls. These. So wing walls are the vertical walls extending from side walls into the channel bank to protect the banks from swirling effect. So as the water velocity is very high inside the dam, so there is a swirling effect at this area. So to protect the banks from swirling effect, the wing walls are used. And last is the apron. So apron is constructed at the downstream below the head wall to dissipate the energy of flowing water and pass with non-erosive velocity. So apron reduces the velocity of water and makes it pass with non-erosive velocity. So you can see the water passes through this apron downstream. So this is how the construction of the wall drop spillway is done. So uses, advantages. So these are some advantages and limitations of the drop spillway. So you can go through your notes. Second, before that,
and store it in water supply, irrigation, hydropower, or flood control. But sometimes we have to let some water go, whether we need it. That we're talking about. Typically, we have rainfall smooth out. It's not a new storm event, so dams need. For this reason, they're let the flood overtop the dam to withstand the biggest storm that we could possibly conceive, called the probable maximum flood. It's too expensive.
you can see this is the dam construction. If the water level exceeds the optimum level, it
build a dam
overflows.
so tall that it can store the entirety of this flood. On the other hand, we can't just let the flood overtop the dam because flowing water can
If
damage
the
and
height
destroy the
of
structure.
this dam is very
So
low,
in most cases, dams are designed with at least one spillway,
yes,
a structure that can safely discharge floodwaters without causing injury or deterioration to the dam. The water stored behind a dam is called its reservoir, and the term spillway is usually reserved for a structure that releases excess inflows when the reservoir many large dams have. Because of that, no matter if the pool is below the crest, no water.
So this is how the drop spillway works. Second is the drop inlet spillway, which consists of a pipe-like structure. You can see the different components are: there is a inlet, riser inlet. Second is the pipe conduit or pipe-like structure, and third is the outlet. So this is how water enters horizontally positioned circular or rectangular box type riser or inlet. So you can see this is the riser or inlet in which the water will enter and flows to some type of outlet protection through circular conduit. So after that it flows through the circular conduit. If the water velocity, if the water discharge is higher, then it will flow through this way to the outlet. That's how the erosive activity is prevented. So it consists of an earthen dam and a pipe spillway. So these are the components. So it is adapted where the drop is greater than 3 meter, where the drop of height of the water to be discharged is greater than 3 meter. The drop inlet structure consists of inlet, conduit and outlet. So these are certain advantages. Next is the chute spillway. It consists of first inlet, which is straight type, flared type and box type. The most common is straight inlet, box type inlet and sometimes channel inlet also used. The box type inlet is most common, and it is generally used when straight type inlet is not sufficient to carry the runoff at the desired drop. Second is the channel section or conduit. So the rectangular or trapezoidal conduits are used. Outlet, third component is outlet. The apron, cantilever and SAF outlets are used. The straight apron type outlets are most commonly used in small gully control structures. So this is how the chute type structure, gully control structure works. So this is the chute. This is called as chute and chute blocks. So you can see these are the rectangular and straight apron type structures. This is another chute type structure. This is similar to the drop spillway, but the shape of this is little different. So this is used where there is steep slope and the drop is greater. And last is the permanent earthen check dam. So it is made of compacted soil. It is made of compacted soil. It is used for increasing infiltration, detention and retention facilities. So it does all the work of infiltration, retention of water and retention of water also. Earthen embankments are generally trapezoidal in shape and most simple and economic in nature, mainly built with clay, sand and gravel. Hence they are also called as earth fill dams or earthen dams. So these are constructed where the foundation of rocks are weak to support the masonry dam, and where the suitable competent rocks are at greater depth. They are relatively smaller in height and broader in base. So these are certain disadvantages. These are not very difficult to grasp, so you can go through it. This is the typical earthen dam, similar to drop spillway. The difference is this is built of clay or stone or bricks. That's the only difference. Thank you.